Okay, now you cut out that template, or I'm sorry, you cut out that trapezoid. So all I did was I cut out, around my lines, the lines that I made, and so now I have a trapezoid. Okay, so I'm actually not going to label that right now. You probably, I'm suspecting that people do not have a protractor at home. Okay, so I'm going to do this by I'm asking you to follow along, but you will not be writing your angles yourself. So I'm going to measure the each of these inside angles. Okay. All right. So here we have I've got uh, I've got my protractor lined up right at the vertice of this line and this line. And I want to measure that inside angle right there. I can see that it's acute, so I'm using the numbers that are less than 90. It appears that's about what? There's 70, there's 80. It appears that that is about 75 degrees. Okay, so I'm going to label this 75 degrees. All right, that's that angle. All right, now I'm going to measure this angle, which looks like I drew really close to 90, but a little bit more. So this is going to be, let's say that's 95, 96, something like that. Pretty close. So this is 96 degrees. That's a little bit obtuse, right? It's a little bit bigger than 90 degrees. And these two inside angles, this one is acute. It's less than 90 degrees. So I'm looking at the numbers that are less than 90 degrees, lining up that bottom line segment, that bottom side, with this line on my protractor. And again, I'm not looking at the big numbers or the bigger numbers because I know that this is acute. So it's going to be less than 90. I can see that it's acute. So I'm looking at these smaller numbers here. So not over 100, but in between 80 and 90. It looks like this is right at what? 80, 84? Yeah, about 84. I'm going to label this as 84 degrees. Okay, and then I will measure that final inside angle. And let's see. So this is obtuse, right? That angle is a little bit bigger than 90 degrees. It is bigger than a right angle. Okay, so let's see here. Okay. And that appears to be about, let's see, about 105. About 105. Oops, I want them all to face the same way. So 105 degrees. All right. So you do not have these measures, but you do have a trapezoid. And I want you to label your trapezoid A, B, C, and D. So you're labeling those angles and putting in, so maybe your trapezoid looks just like, oh, look, I've got a ready-made trapezoid. Well, almost ready-made. So your trapezoid might look something like this, and you would just have A, B, C, D, right? So yours looks like that. Mine has measures in it. Okay, mine, because I was able to measure them. All right, now what I'm going to do and what you are going to do is take your scissors and make this a little bit bigger. Take your scissors and cut in between, let's see, side, or cut in between these two sides, this side and this side, and it can be kind of a squiggly line like that. Okay. So I cut my trapezoid apart. You're doing the same thing. So the only thing that you don't have are the measures. And I'm going to cut it apart this way too. Two squiggly lines. Okay, so I have cut my trapezoid apart. And you should have the same thing. I'll put your trapezoid back together and it should fit back together perfectly. Now, here's the thing that I want to show you. Here's a very important part of this whole lesson is if I take B, angle B and angle C, and I put them together like that, it makes a straight angle, right? Okay, so angle B and angle C, put them together like that, it makes a straight angle because the sum of angle B and C is 180 degrees. Okay, sum of angle B plus angle C, that's the angle sign, equals 180. Okay, and put those over here. The sum of angles, come on, there we go. The sum of angles A and D also equals 180. So, and by the way, the angle B and C, that was 84 degrees plus 96 degrees. So you can see 84 and 96 is 180. And the sum of angle A and angle D is also 180 degrees. I can see that that is a straight line, or close to a straight line. That is a straight line. That is 180 degrees. So that's 75 and 105. So angle A, 105 degrees plus 75 degrees. That is 180 degrees. And then, even more interesting, and I want you to experiment with this too, explore this too. Even more interesting is the sum of all of the internal angles. The sum of all of these internal angles is 360 degrees. Sum of all internal angles equals 360 degrees. Okay, so that is the case for, let's see if I can put this back together. A, B, C, D, A, B, C. I'm not very good at puzzles, or at jigsaw puzzles, I should say. Okay. All right. The sum of the interior angles of all quadrilaterals is 360 degrees. Trapezoid is a quadrilateral, and the sum of the interior angles is 360 degrees. This plus this plus this plus this is 360. The sum of the internal angles on the opposite sides that are parallel, those are going to be 180 degrees. So this plus this, because this is my parallel line, and this is my parallel line. This line and this line are not parallel. Those are line segments, by the way. This line segment and this line segment are not parallel. Okay, backtrack. This line segment, A, D, and this line segment, B, C, are not parallel. A, B is parallel to D, C, parallel, parallel. 84 and 96, these two internal angles equal 180 degrees. These two internal angles equal 180 degrees. The sum. This and this do not, because those aren't the parallel lines. A and B do not equal 180 degrees, because those are not the parallel lines. Okay, so that is a defining characteristic of a trapezoid. And write this down, maybe somewhere, any place where you're taking notes here. Write this down. This is similar to what we looked at yesterday. A trapezoid is a quadrilateral in which at least one pair of opposite sides is parallel. Okay? All right, good.